So we looked at the basics of polynomials and the fact that they had to have natural number exponents, and we talked about monomials, binomials, and trinomials. Now we're going to get into the degree of polynomials. And there's a distinction that has to be made first between discussing the degree of a term and the degree of an entire polynomial. So I'll give you a quick example here. If I have a polynomial expression such as 2 x to the fourth y squared minus 3 x cubed y plus 2x squared y minus 3x plus 4. That's actually a 5-term polynomial, right? Which there's not a name for, right? We have a name for a monomial, 1 term, binomial, 2 terms, trinomial, 3 terms. So anything outside of those, you would just say is a general polynomial. This happens to be a 5-term polynomial. All right. So the first thing is just figure out what all the degrees of each term are, right? That's the first thing there. The first thing up in this box says the degree of a polynomial term is just the sum of all the exponents of the variables in that term. So in this case, we have 2 variables we're dealing with. We have x and y. So what we've got to do is we've got to add up in each term the exponents of those variables. Right? And the little highlighted colors that don't have any number in there, again, you got to realize are really 1. Right? If you just see a y there, it's really y to the first. If you see just an x there, it's really x to the first. Okay? So the degree of the first term here is just 4 plus 2. So this would be degree 6, or 6th degree. This one you would do 3 plus 1, so this one would be degree 4, or 4th degree. Here you do 2 plus 1, so you get degree 3. Here you don't have anything to add, it's just 1, so this is just degree 1. And actually, we didn't do this, but a constant term, think about if there's a variable here, x, or xy, whatever it was. Any variable that was here would have to just be 1, right? Because 4x is not the same as 4. So this x would actually have to be 1. So how can you make anything turn into 1? You give it an exponent of 0. So actually, any constant is always going to be a 0 degree or degree 0 term. Right? So I went there, I had a 6th degree term, I had a 4th degree term, I had a 3rd degree term, I had a 1st degree term, and I had a 0 degree term, which is really just a constant. Right? Usually they would just call it a constant term. You don't really hear 0 degree term too often. They would usually call it constant term. But realize that a constant is really a degree 0. Okay? So that would be the degrees of each term. Now, what's the degree of a polynomial? So that's the second thing. The degree of a polynomial is its highest degree term. So what you don't do, and this is the mistake that I think people make a lot of times, is they'll start adding these up and say, oh, 6 plus 4 plus 3 plus 1 plus 0, so it's 6, 10, 13, 14 degree. What you do is the degree of the polynomial is just the highest degree term, right? So I had 6, 4, 3, 1, and 0, so out of those, the highest degree is degree 6. So this thing here as a whole would be a 6th degree polynomial, because that would be the highest degree term, right? So you always just take the highest degree term, and then that's that's going to be the degree of the polynomial. All right? So it's a pretty basic thing. And I mean, it's even easier when there's only one variable, because when there's only one variable, you don't even have to add degrees, because each term is just going to be whatever the exponent is. Right? So this one was a little bit more complicated because I actually had 2 variables, so I had to add up the degrees there. But in general, if it only has one variable, it's even easier than that.